Hello, everyone, and thank you so much for joining today's session. Huge shout out to Alejandro and the Silicon Valley Certification Hub for giving me this opportunity to talk on AI agents. Shout out to them and do check out their website. They have some really valuable AI certifications. So, my name is Divsehaj Anand. I am a senior AI associate at Thotnr Consulting, where I work with Whole Insurance on implementing enterprise AI solutions. What I'm going to share today comes from my research, reading white papers, studying latest implementations, analyzing what's working and what's failing in the field, but also enriched by my hands-on experience from my personal projects, my work for Holard, and most importantly, my interactions with various AI engineers and industry experts who have been generous enough to share the real world success and failures. So today I'm here to not sell you anything. I'm here to share the uncomfortable truths about building agentic AI for enterprise, a mix of my experience plus the collective wisdom of other AI engineers I had the privilege to learn from. So let's dive in. Building agentic AI for enterprise, from architecture to real world implementation. But before we talk about architecture or implementation, we need to talk about failure. 90%, 95% failure rate. That's not needs improvement. That's failing. 95% of enterprise generative AI pilots are failing to scale beyond initial deployment. $2.6 billion in capital wasted. That's not just investment lost on failed AI in 2024 alone. That's a conservative estimate. And only 5% of the companies actually scale beyond pilot programs. I spent around 2 years working with Fortune 500 companies implementing Agentic AI, and I have watched billions evaporate because of one fundamental mistake. They're feeding the systems garbage data. Today, I'll share what the 5% do to actually succeed. And I promise you, it's not what the vendors are selling. According to the MIT NANDA study, 95% of generative AI pilots fail to scale. They studied 150 companies over 12 months, not vendor success stories, real companies with real budgets and real failures. Gartner's prediction, 40% of the agentic AI projects will be cancelled by the end of 2027. Cancelled, not paused, not delayed, shut down. According to McKinsey's report, 80% plus companies report zero earnings contribution from their AI initiatives. Zero. Now, here's what's fascinating. The technology isn't failing. ChatGPT 4, Claude, Gemini, these models are extraordinary. They're advancing rapidly every quarter. So why are the 95% projects failing? The problem isn't Silicon Valley. It's in your data center. Let me paint you a picture, and I want you to be brutally honest with yourself as I describe this. You have an 8-year-old SharePoint system, documents from 2016, sitting next to files from last week. The same quarterly report exists in different folders with slightly different names. Nobody knows which version is current. Your metadata either missing or completely inconsistent. I'm seeing some knowing looks, and here's the kicker. 42% of enterprises need 8 or more different data sources just to deploy a single AI agent. 8 different systems, 8 different data formats, 8 different quality levels. Now we take this mess, this organizational chaos, but built over decades, and we expect our AI just to work. The research is clear. Rack performance degrades dramatically at scale when data quality is poor. Contextual retrieval becomes unreliable. Output quality becomes deteriorates. So here's what you need to understand. Before you build AI agents, before you deploy AI, before you do anything, fix your data foundation. I know that's not exciting. I know what you want to talk about autonomous agents and intelligent systems. But the 5% who succeed, they start here with data. So what does fixing your data actually mean? There are 4 critical steps involved in it. Number one, structural structure audit. Identify the ratio of structured versus unstructured data. Most companies shocked to find that 80% of the data is unstructured. You need to know what you're dealing with before you can fix it. Number two, data lineage. Map where your data comes from, how it flows through your systems, who owns it. I've seen multi-million dollar projects die because nobody could answer the basic questions. Number three, quality assessment. Measure completeness, accuracy, consistency, timeliness, but real numbers to data quality, not opinions, not feelings, actual metrics. Number four, access patterns. Document how your application and users currently retrieve data. Your AI agents will need to follow similar patterns for security and compliance. And here's the truth: clean, contextualized, categorized data is the foundation that works. Not the biggest AI model, not the fanciest architecture, clean data. That's it. This is a secret. Now, coming to the RAG architecture that works. Once you have clean data, you need the right retrieval architecture. There are three critical components to it. First, the hierarchical retrieval, multi-level indexing, document level, section level, paragraph level. Your AI agents need context at different scales, not just finite well token chunks thrown together. Context matters at every level. Second, hybrid approach combines semantic approach with keyword matching. Semantic search is powerful, but sometimes old-fashioned. Keyword search is exactly what's needed. The best systems use both. Third, security. Role-based access at the retrieval level with complete audit trails. If your AI agent can retrieve data that someone shouldn't see, you haven't just built an AI system, you've created a security vulnerability. And I'll be clear here, chunking strategies matter. Security cannot be an afterthought. Multi-tenancy requires isolated indexes. Context preservation is non-negotiable. These aren't optional features. They are the difference between a working system and a security incident. So choose wisely. Now, how do you actually connect all this to your enterprise applications? There are four principles which I've listed down here. The first being AI first architecture, API first architecture. Build abstraction layers between your RAG system and your applications. Why? Because things change faster than we expect, always. Real time versus batch. Customer support needs real time retrieval. Customers are waiting. Analytics reports. Those can use cheaper batch processing overnight. Match your architecture to the required use case. Application specific tuning. Your customer service system needs different retrieval parameters than your compliance system. One size never fits all or in all enterprise environments. Feedback loops. Track which retrieval leads to successful outcomes. Use that data to optimize continuously. The 5% who succeed treat as a learning system, not a deploy and forget integration. Be a part of the 5%. All right, time for some radical honesty, and I need us to be brutally honest with ourselves and our stakeholders. We cannot handle complex tabular we cannot handle complex tabular data. Multiple studies show how LLMs fail at structured calculations and multi-table reasoning. This isn't a maybe, they fail consistently. Terrible at precise arithmetic. If you need calculations, use specialized tools, not language models. Don't put your financial calculations through an LLM and hope for the best. No real-time data knowledge. These models don't know what happened this morning without explicit updates. It's not magic. It's a trained model with knowledge cutoff. Unpredictable without constraints. The same prompt gives different answers. This is a catastrophic for enterprise systems where consistency is everything. Lack of domain expertise. Generic models trained on the internet don't understand your industry nuances, your company specific processes, your regulatory environment. So what do you do? The modesty principle. Start narrow. Build confidence through small wins. Augment with specialized tools. Let agents do what they're good at: language understanding, summarization, routing, and nothing more for now. These companies that succeed, they're honest about their limitations from day one. Constraining stochasticity. Now let's talk about the biggest technical challenge in enterprise AI: stochasticity or randomness. LLMs are probably machines generating different outputs every time. This is wonderful for creating writing. It's a catastrophic for enterprise systems. So, how do we fix it? There are four critical constraints to it. The first being temperature control, set to zero point 0.0 to zero point 0.3 for deterministic outputs. I see companies running enterprise systems at zero point 0.7 temperature and wondering why their outputs are inconsistent. That's like being surprised your car drifts when you're not holding the steering wheel. Output enforcement. JSON schemas, validation layers reject anything that doesn't match the expected format. No exceptions ever. Confidence thresholds. Your system should know when it's uncertain. Require minimum confidence scores for autonomous action. Route uncertain cases to humans. We can look at fallback mechanisms. Clear strategies for when things fail, and they will fail. Have rule-based backups ready. Never ever fail silently. And here's how I think about it. Unconstrained LLMs are creativity engines. Constrained LLMs are enterprise tools. So the 5% who succeed constrain aggressively from day one. Be aggressive with your constraints. Let's bring everything together and how do data and applications actually drive decisions in an agentic system. Step one, data collection. Gather information from enterprise sources with quality checks, not just grabbing data, verifying it meets your standards. This is where the data cleanup work pays off. Step two, context assembly. Your ad system retrieves relevant industry information or history and business rules. This is where the architecture will actually work. All the data cleanup, all those constraints. This is where it all pays off. Step three, the analysis. The LLM processes information within defined constraints, right? So the temperature controlled, outputs validated, confidence measured, everything we've discussed, or everything comes together here. And finally, the decision gate. High confidence enables autonomous action. Low confidence triggers human review. Always the safety net, right? And before any decision, we should ask this critical question: what's the cost of a wrong decision? If wrong decision cost millions of dollars or breaks regulations, your confidence threshold should be very, very, very high. This question should govern every threshold we set in our enterprise or any agentic AI system. So we should never forget to ask these questions. So let me bring all this together. We started with an uncomfortable truth: 95% projects fail, billions of dollars wasted, but only 5% succeeded. But now we know why. 95% chase the hype. They believe the vendor promises. They skip the data work. They deploy without constraints. They ignore the limitations. And the 5% do something entirely different. They fix the data foundation first, even though it's not glamorous. They build RAGs architecture with security from day one and not just overnight. They're radically honest about LLM limitations with their teams and their stakeholders. That their constraints, they constrain aggressively because unconstrained LLMs are creativity engines, but constrained LLMs are enterprise tools. And they always ask, what's the cost of a wrong decision? The choice is yours. Be a part of the 95% who fail, or hope for some magic. Or you can join the 5% who succeed by building on truth, starting with data, and respecting reality. So, thank you so much, everyone, for your time today. I'm happy to take any questions via email, LinkedIn, or in the comment section. Thank you.